So right now we have with us Dario Pedro, CEO of Beyond Vision, a company based in Portugal. And he's going to present a talk entitled Fully Autonomous Drones from the Design Board to the Skies. So Dario Pedro, thanks for joining us in our workshop and accepting our invitation. And the floor is yours.
Hello, everyone. Thank you for the invitation. I'll now share my screen. Not sure if you are watching it.
Yeah, sure.
Yes.
Okay, let me just minimize Zoom. Okay, so with this presentation, I want to give you a brief introduction regarding drones and what they could be applied for. I'll try to approach all areas of expertise regarding drones, and a bit of description from myself. I'm Dário Pedro. I have a PhD in artificial intelligence applied to UAVs, mainly in the area of collision avoidance. And I'm currently the CEO of Beyond Vision, and I'll give a little bit detail about that in the next slides. So this presentation will be structured as follow. Initially, I'll go through the general insights of the presentation. Then I'll touch a little bit on mechanics of our UAVs, then the electronics, then the software part, or what makes the control and the algorithms on the drone. Also, we developed a custom cloud platform that allows to control the drones in real time and handle all the sort of algorithms. It's called BXtreme, will be the 5th point, and then some final results and what everything could be used for. So regarding general insights, so Beyond Vision is initially funded in 2014. The idea initially was to just do R&D. And then the first years was exactly that the company did. In 2018, we had some really good results with, sorry? I'm hearing some background noise, not sure if it was a question, so I'll just move forward. If you need anything, don't have any problem interrupting me. So initially in 2018, we developed our first prototype. It was called HEIFU, and a lot of partners from research projects wanted to purchase it. So we couldn't do it because it was being used on multiple research projects. So we started enlarging the team and hiring new people so we could turn that drone into a product. And that's what happened in the following years. So basically, we developed all the ecosystem around that drone. We did the certifications and all the integrations required for the drone to make it a commercial grade product. Due to the success of that prototype, we were invited to multiple new R&D projects. And right now we are one of the most, or the PDM group with the help of Beyond Vision is one of the most successful and one of the most involved companies in R&D projects at least a private company. We are in more than 20 projects right now. And we right now are also developing hybrid VTOL aircraft. So basically our aircraft that have fixed wing and multi-rotor, so you can achieve way larger autonomies. So regarding our tech developed, we are a OEM UAV manufacturer with the focus on the multiple communication protocols on the board of the drone and running AI algorithms directly on the board of the drone. We make mechanisms, both mechanical and electronic, to make our drone really easy to integrate to different use cases. And we follow NATO guidelines on that regard. We also develop a cloud platform that allows you to automatically manage all the data that you generate and work with all the data that you generate through the drone flights and get value information from it. You can also control your drones remotely to the platform, and I'll give a little bit more detail in that regard further ahead. We also develop specific solutions for certain areas, for example, precision farming. And the last slides on the conclusions, I'll also give more details on that area, but we are working on other areas such as security, power line inspection, autonomous deliveries, and so forth. So this is just a render of our main aircraft, HEIFU. It has multiple payloads that it's able to handle, and it's quickly adapt to each of them. So multispectral cameras, 368K cameras, high definition and depth cameras, zoom cameras, thermal cameras, robotic arms, transportation box. Most of the payloads are really quick to adapt to the drone, and then you can control them to the platform. For example, the 368K camera, we won an award because we were able to, via 5G, control the drone with AR glasses, and you could like go wherever you want, where you're facing, and you just move the drone forward. The new aircrafts that I was talking about are similar to this, the hybrid VTOLs. So they have fixed wing which extend autonomy, and multi-rotor, which allows you to do the operation that you usually do on a drone. So take off and land on with the exact precision on one spot. So regarding the communications, the most used ones are Zigbee, Wi-Fi, 4G, 5G, and then we have RTK communication with multiple base stations. We also have LoRa and Bluetooth, but those are just for specific use cases. Looking a little bit in detail to the mechanics of the drone. So we usually follow these steps. So you initially do a conceptual approach, then a feasibility analysis. Afterwards, we go through a simplified version of wing selections. Then we generate a CAD concept of the aircraft. Then you do CFD validation. With the errors of CFD, most of the times we have to rework the CADs. Then we trim the CG, CEA of the aircraft. We do the CAD model update, and then we generate a structure, design, and analysis. Right now we're using ANSYS for this. And this goes back to trimming the CG and CA. At the end, we do a fluid structural interpretation analysis, with most of the times force us to go back to the CFD validation. And when we have like a really good structural analysis, we go to make control surfaces, basically. So these are some cool graphs that we are able to generate with our simulation software. This is a case of studying the pressure points at certain speeds on the aircraft. But I'll go with more detail in the HEIFU, because I think it's an easier drone to explain than hybrid aircrafts. And with the given time we have, I think it's better to stick with HEIFU. So this is an exploded vision of all the components inside the drone, and you try to optimize component by component. So just a simple overview of how this kind of hexacopters fly. The X layout hexacopters have 6 rotors. So some of them rotate clockwise, others rotate counterclockwise. And with these motions, you generate lift, and affecting some motors more than others makes the drone go to a certain direction. So just looking at the chassis of the drone, if you look at the center part of the chassis, a mechanic analysis initially is to study the static effects of certain movements of the drone. And then we do a dynamic study of the same effects on the drone. And you can see that the pressure areas that are mostly affected, and sometimes you need to redesign some parts to be able to achieve the goals that you want. We also have to work on electronics. So this is a rough idea of the electronic board that we developed for our drone. It has a power area where it handles the battery, the power options board for the drone. So basically it's a module that allows you, it's on the bottom part of the drone, and allows you to quickly adapt sensors, a power switch mechanism. So when the drone is connected, if you swap between payloads, it doesn't affect the normal control board. Then on the board, you have a flight controller and a CPU board. So basically the flight controller is handling the flight operator controls and also the flight mode of the drone. And the CPU board, usually you use it to run AI algorithms or communicate with the cloud platform. You have multiple internet connections, you have telemetry links, position, you use a ZF9P for highest precision possible. It integrates almost all the satellite constellations. Then we have the payloads. the motors connections. So they are 24 volts, 40 amperes per motor, and we have an autonomous landing gear mechanism. So this is how the board looks. So you can see here the computer module and also the controller or a flight unit. And on the bottom part, you have some communication modules. For example, the bottom one is the SIM 7600E is a LTE module. Some of the algorithms that we developed for the drone follow this approach. So basically, we have a loop between the flight controller and the onboard computer. Usually the onboard computer sends information to the flight controller and it receives some kind of feedback or control state from it. So on the flight controller, it's mainly focused on flying the drone basically, and the onboard computer is focused on doing some sort of algorithms that you want with your payloads. We tried to use as a starting point open software. So we have a custom version of ArduPilot that is developed over PX4, and we have a custom open software module called HEIFU that was developed in Roche. Regarding the collision avoidance algorithm, basically we have a module that is estimating the surroundings of the drone. With that, it generates GPU voxels. And then we have an algorithm that looks at the GPU voxels and generates a safe path or a minimum cost path, but also interpolates the waypoints that the user presented to the drone. Then a priority manager looks at everything. So the plan that the user made, if it's receiving any inputs, the obstacle avoidance algorithm and the control states, and then send information to the Mavros and the Mavros to the control on the drone. And if any input of the operator is done likewise, usually it takes control and makes a step forward and goes directly to the autopilot. So you basically doing these 4 steps. Initially, you do the sensing, where you collect data from the sensor. Usually for collision avoidance, you're looking at LiDAR data. Then a perception algorithms, that the GPU voxels part, the decision making from the planner, and then the action on the controller. With this, you can really improve the cloud quality, and with that reduce the costs of the UAVs if you have some remote computing on premises. So basically, with the communication algorithms, we can reduce some of the costs of our UAVs. These I'll go really quickly, but are some of the payloads that we usually integrate on the drone. So depth, high quality cameras, depth cameras, multispectral cameras. Usually use those more for agriculture purposes. FleetView Pro Air is a thermal camera. There's the Altum camera that integrates multispectral with thermal, the 360-degree cameras, and then LiDARs. We use the Velodyne POC for most standard applications, but we also have the Oyster OS1 already integrated with the drone. The advantage of this LiDAR is that it also gives you some information regarding the each point that it detected, information such as like some indices of reflection of that point. And then we can go to the last part of our development, that is the BX-Stream Clouds platform. So basically, the fundamentals of this platform, it's that it's capable of remote controlling multiple drones at once. When we started this application, we had the idea, or the concept idea, to have a completely distributed application where no pilot was needed and someone could stay on a cloud, let's call it that way, and control whatever drones they needed and just look at the results afterwards. And then we make it in such a way that it's suitable for small and large enterprise. So basically, on large enterprise, you can set up everything from roles, different permissions, different users, different areas, and you combine all of that to have different panels, so to say, to each user. So I already touched a little bit on these points. So the core of this platform is to be able to total remote control your aircrafts and handle all the data in a single platform. On here you can see a panel that shows some of the details of your fleet. So the latest flights and the status of your aircrafts. On this you can see how it is, like it's on an image, but it's hard to show it on a presentation. But the idea of how it is to control the aircraft, you have the remote live stream on the bottom part. You can even swap the map to the live feed of the drone if you prefer. And then you have all the telemetry of the aircraft. You can also design autonomous missions on this platform and send it remotely to the drone. And with the data, for example, from the multispectral cameras, you can take it and generate maps. We do every type of maps on the platform. So NDVI, SEER, 3D point cloud maps, and so forth. So basically, to generate a map is as simple as this. You just go to the platform, generate a new map, and drag and drop a zip file. Only if you didn't have connection on the drone. So this is important to say. So the images can be directly uploaded on the flight to the platform, but if you don't have internet, you can just remove it from the drone and put it on the platform and select what you want to do with them. Afterwards, you can do some sort of analytics on the maps. For example, you can see what's the area on a given region. You can do temporal comparisons. For example, if you do multiple maps on an area and you want to see how that area evolved over time, you can go to the comparison menu and see how it progresses during those 2 days and how it evolved. You can also do some 3D analytics. So, for example, if you want to estimate a farm productivity, you can generate a point cloud or a 3D map, so to say, and then measure a volume of a certain region. These volumes are convex Hull volumes. So basically it just calculates the volume of the overlaying mesh to the bottom. And with that, you can calculate the productivity of a certain region or estimate the productivity of a certain region. And this was everything from my side. I'm not sure if you have any questions.
So thank you very much, Dario, for this nice presentation. So thank you very much for joining us and accept our invitation. So any questions regarding the presentation of Dario?
Well, I was writing, but probably it's better to speak. Thank you, Dario, very much for your nice presentation. I just have one doubt because I'm not expert on this. When you do mention to use volume to calculate productivity,
Yes.
this can be applied only to certain crops, I believe.
I think it can be applied to a lot of different crops. On our side, we just developed the technology to allow third-party users to apply it, so to say. But for example, we had use cases that they just wanted to calculate biomass quantities, for example, near roads or something like that. So on those cases, I think they don't really care of what species are in there. But for estimation of productivity, it usually used for vineyards.
Okay, and this could be interesting for controlling, for example, forest management and so on.
Yeah, exactly.
Okay. And do you measure soil parameters as well with your drones or not?
We just generate the maps, but we had use cases where other partners used our maps to try to understand some comparisons between different areas of the soil.
Okay, nice. Thank you very much for your participation.
Albert, may I ask a question?
Yeah, sure. Go ahead.
Okay, regarding the payload, I think you are only manufacturing the drones, not the cameras and sensors, right? Am I
Yes,
understand?
we have one sensor that we do ourselves, but mostly we are not payload manufacturer, so to
Yeah,
say.
okay. And what is the maximum payload for cameras and sensors to take on board?
8
The
kilos.
weight, 8 kilos.
Yeah.
Okay, and then regarding the mosaicing software, did I understand correctly that you also develop your own mosaicing software for stitching the images from
Yes.
different cameras?
We try to make it as generic as possible.
Yeah.
But yeah, sometimes you need to know which camera generated. For example, for thermal cameras, it's good to not fly just with a thermal camera, so to say. For example, if you have any sort of image or multispectral camera on board of the drone, we try to extract features from those cameras and then apply the features on the thermal image.
Could you just briefly mention about the accuracy of your stitching or mosaicing software?
Which parameters of performance?
Geometric accuracy, for example, the X and Y, and also the height accuracy, the Z for in case you measure the volume, the height of, for example, maize crops.
I'm not, I can't give you for that use case like a number, but it's at a centimetric level. So I would say 10 centimeters, 20 perhaps.
Yeah. Okay, looks impressive. That's very good. And also, if I may, Albert, I don't know, time is short. Just the last question for now. It's very interesting presentation. I enjoyed it very much. Regarding also, are you open for example, I'm using DJI, let's say, platform with a DJI sensor.
Yeah.
Then can I upload the data that I acquire with my drone and sensor, or maybe with our spectrocam, and then upload it in your platform, and then you provide the mosaicing, stitching?
Yeah, you can.
Also, okay.
So sorry for the presentation was like really quick, but to be honest, I thought that the presentation was
No, I understand. No,
so
no,
1 hour from now, and I didn't connect any monitor. So when I was presenting, I had no idea of the time.
No. It was
so
pretty
fast
good
forward.
time limitations, and as a technical person, you expose us to, yeah, you open the floor for more discussion and collaboration.
Yeah, so I think I have more time to questions now.
Yeah, thank you. No, I enjoyed it very much. Thank you.
Yeah, so to give a little more details, you can just drag and drop your zip files from any standard DJI RGB camera. From RGB, it's quite hard to run our AI algorithms because they are more fine-tuned to multispectral data. But for example, on Vineyard, some of our algorithms detect automatically some fails. So some areas where it was supposed to grow crops and it didn't. And for example, for thermal cameras, you can automatically detect some water irrigation problems. But if you just want the 3D point clouds or the RGB map, it's similar to DJI software. So
cool. Thank you.
Thank you. There's 2 more questions. One is, what is the future market for agricultural drones, robots, and other electronic products? Will it be affordable to the farmers in the developing countries?
I mean, so the future, I think there's a lot of applications. There's nowadays there is a gigantic lack of human resources on the agriculture fields. I'm not an expert, but the contact that we have with most farmers, this is the input I'm receiving from them. And everything that could save them time and allow the people or the workers to do other tasks, it would be helpful. And with more information, they can better manage their farms. Usually what happened is that it is like some sort of a service provider that purchases the drone and then does the service for multiple farms, or large farms acquiring the drones. The underdeveloped countries, I think there are still earlier problems that they need to solve before going all in with such like optimization technologies.
Okay. And another question, do you provide a service like linking the GA Matrix 3000 RTK, or it must be your own drone?
What do you mean by linking? So we can use our cloud platform to fly other drones. We have integrated, for example, Parrot drones, and we had a partner from a research project that was able to integrate a DJI Matrix 300 on our platform and fly it from there. But I'm not sure if I correctly understand the question. What do you mean by service like linking?
We can invite Abdel Majed to open its microphone, and if he wants to ask directly.
Good afternoon.
Hi, good afternoon.
Hi.
Hello.
Thank you for the nice presentation. That was great.
Thank you.
Concerning my question, that was, is that like possible to link some service to any ready-made, not your own drone, for example, like the DJI Matrix 300 I have here, to, for example, the service you are providing, like cloud computing and the other services you provide on your platform? That was the question. Or
Okay,
it must be your own drone, like I have to buy the drone from you?
It doesn't need to be our drone. So the platform itself has over 300 APIs that you can integrate on your own system. And our drone HEIFU uses a ROS module, so to say, or package, it's what is called in ROS, to make the integration with the cloud. And I know that DJI also has a ROS package for their drones. It's just a matter of calling the right endpoints to sending the information.
So it's possible to, once I have, for example, the platform from your platform, it's possible to use my own drone, like
yes,
this is what I mentioned.
Yes, it is.
Great. That's great. The second issue, the second question I was typing, that concerning the cloud computing you mentioned, as I got that, starting from the flight plan, I think that I can start autonomously fly my drone, starting from setting the flight plan, ending with the calculation for some indices in the farm, right?
Could you repeat the last part? I had like a small cut on your voice.
The cloud computing part, is it starting from setting the plan on the cloud, on the website, and fly the drone autonomously, and ending with calculation some indices for my farm? Specifically, I'm talking about precision agriculture service you provide.
So you don't need to do all the steps. So for example, use the DJI 300 drone. You can do the flight mission on your drone like you're used to and just send the data to the platform and obtain the results. But if you want to go like full integrated, you can do the missions autonomously from the platform. And on the flights, when the drone is flying, send the data to the platform, and at the end it will have the map generated, so to say. So they are just like multiple modules. You don't have to use them all. You can just use the ones that you want. For example, we have partners that just want to do security on a certain region, so they just fly the drones on the platform and they just don't care anything regarding maps. They just fly the drones, and when they see something wrong, so to say, they make an annotation on a certain area saying, oh, this must be checked personally, and or something is odd, and they leave a drone like an aerial camera on a certain area.
So far, I'd like to get some more details about the platform, if you don't mind. So, but I will drop my email if you can.
Okay. Can send you an email with a few links.
Thank you very much for that.
Thank you.
Thank you very much for the question. Any other question to Dario? I think that not. So thank you very much, Dario, for your nice presentation and for accepting our invitation to participate in this workshop.
Thank you, everyone.
Have
a nice workshop.
Thank you, Mario. Goodbye.
And